So a computer's instruction set is the patterns of zeros and ones that a particular processor recognizes as commands. So different processors have different instruction sets. Some have different size operands, operators, and amount of possible instructions. So I've already mentioned instruction set quite a lot in the decode area of the fetch, decode, execute video. So I would advise you to go back there and understand what I mean by operands, operators, the different amount of possible instructions. So essentially, an instruction, let's say it was a 64-bit instruction, comes through to the processor, you could have 10 bits assigned to your operator, your opcode, and then this opcode will determine how many possible instructions you could have. And then what it does is once it's got a set code, so it could be say 9 zeros and a 1, it would then look up those 9 zeros and 1 in its instruction set, working a little bit like the ASCII table, and it would find out what that instruction is to that CPU architecture. Now, it's important to understand with the instruction sets that different CPUs have different instruction sets. So, therefore, once code is compiled and run, it won't work on every CPU architecture because the combination of zeros and ones that means Microsoft Word on one program, on one computer, might not be the same combination of zeros and ones that mean Microsoft Word on a different computer. So one program can have different ones and zeros on different CPU architectures, but it's still the same program. It just depends on it's all built around their instruction set. Okay, hopefully that makes sense. But like I say, the code area of the fetch, decode, execute cycle goes over why this is important, I think, in a little bit more detail.